friends, welcome to my YouTube channel. So another shear force and bending moment diagram for cantilever beam I brought for you. So now what is there? 2-point load, one UDL is there. So cantilever beam already told one end is fixed, other end is free, and given load free end 2.5, 0.5 meter distance, 1 kilonewton UDL, 2 meter length, then 3 kilonewton 1 meter length from the point A. So how to solve this? So as basic things already we discussed previous video and all, here also we'll discuss what is the required for the basic. So we start the solutions here. So first find the bend shear force calculation. Shear force diagram calculations we are starting. So what is the sign conventions? I am mentioning always here. So this is the section. If downward force will be right side, will be positive. From the left side, upward force will be the positive. Okay, this is the section. This is the section. Section right side positive, downward force. Section left side, upward force, positive. Okay, so these things just will extend this line. So it will be helpful for us to draw the shear force diagram. So always in this junction point we have to draw like this line. So this all points and all will draw when shear force diagram it will be required. Okay. So first we'll do the calculation part. So this is the sign conventions we are following. So at point B, S means shear force at B will be at the point load is there 2.5 kilonewton, downward force positive. So how much? 2.5 kilonewton shear force for the point B. Now at point C, if you will see this calculation of the C, no load in between C and B, no load between C and B. So same things will be there. How much? 2.5 kilonewton. Same load will be there. Now at D, shear force at D. So up to C what is there? 2.5 kilonewton will add, because shear force definition is telling total force either left side or right side, that is called summation of this is called shear force. So we are adding 2.5 up to C. So that means shear force we have to find up to that only. So plus 1 into 2, this is called load, because UDL is there, no? UDL is there, no? This load into distance. So per unit length is there. 1 kilonewton per meter into 1 into 2 meters. So 2 meter. So this is the 2 to 4.5 kilonewton shear force at D. Now shear force at E. You can write here itself. Shear force at E. So how much is there here? 4.5 up to D. Up to D. So what will add here? 3. So 7.5 kilonewton. What is coming this one? Shear force at E. Shear force at E 7.5 kilonewton. Now shear force at A. Finally, shear force at A. So up to E how much? 7.5. In between A and E no load. So same shear force will be there. Same shear force will be there. That means reaction force at A, how much will act? 7.5. If you will add 3 plus 1 into 2 plus 2.5. So 2, 3, 5 plus 2, 7.5. So total load, suppose your reactions will calculate here, now it will come 7.5 kilonewton only. Okay. So that means shear force calculation is correct only. Shear force calculation is correct only. Okay. So now we will draw the shear force diagram. Now we will draw the shear force diagram. So first we will draw the zero line here. First we will draw the zero line. This enough. Okay. So this baseline is called zero line. So in this line, shear force will be 0 we are considering. So this point shear force will be 0, 0, everywhere 0. So that's called shear force 0 line. So now B point, what is the shear force here? Because upward is positive. So 2.5 at B, 2.5. In between C and B, no load. So draw the horizontal line. In between CB, no load, draw the horizontal line. Again, we are seeing here C to D UDL. So already we told previous video also, suppose we have point load, straight line will draw. If you have UDL, inclined line will draw. This is called UDL ke inclined line will draw. Okay. So here what will be there? Inclined line. This will draw the inclined line. This point is C, this point is D. C 2.5. Here how much D? Shear force D 4.5. Now in between E and D, no load. No load also horizontal line. See? No load horizontal line. Now point load is there. Point load means sudden change will be there. So sudden change will be there up to 7.5. After AE, no load. So what will do there? Horizontal line. No load also horizontal line. Make this is solid line. Make it solid line. Draw the hatch part. This part will be the shear force diagram. We got it. So this way we can draw the shear force diagram. So this we can write positive and shear force diagram you can write the shear force diagram. Okay, so this point is 7.5. This also point A. This point is E D C B. This is shear force diagram. Okay, so this way we can calculate. How much simple if you remember the sign convention and how to draw the line, inclined line where horizontal line there, we can calculate. Okay, now we'll go the bending moment calculation. Bending moment diagram calculation. Okay, so now at point B, so I'm writing bending moment MB, that means bending moment at point B. So at point B, we know the already moment is nothing but force into perpendicular distance. So at point B, moment will be 0 because force is there 2.5 but no length. So that means bending moment will be 0. If we'll take MC, bending moment at C. So now in this point, due to this point, this 2.5 kilonewton, it will come the clockwise. So here also sign conventions will take section clockwise negative, anti-clockwise, this is called right side, this is called left side, anti-clockwise ACW negative. This is the sign conventions ACW, sign left side, right side. We are taking right side. So clockwise moment. See, if your point fix 2.5 will rotate. This line will rotate clockwise. So 2.5 into force into perpendicular distance. So negative 2.5 into 0.5. This is the moment will be there. How much? 2.5 into 5 will come 1.25 kilonewton meter. 1.25 kilonewton meter. This is the MC, moment about C. Now we'll take the moment about D. Carefully watch all those things. So similar method, whatever load, how many point load, how many UDL they will give, everything will be same concept. Okay. So take first negative. Why negative? Because due to the sign convention, negative taken. Then 2.5 force into perpendicular distance. We are taking from the D. So what is the length? 2.5. This is 0.5 meter. 2.5. What is 2.5 length? So this over. Now plus, because minus already taken common, so inside everything will write plus only. Now at point D, UDL. UDL what is? Load will convert 1 into 2. This is load. Then half distance 2 by 2. Half distance 2. This already explained so many times. If see this particular diagram, if you draw the load diagram, so how will come? Just 1 minute, you see here. Load diagram if you draw. This is the load, 3 kilonewton. This is E. This is E, DE, D and C, and here point load. Okay. So if you will convert all the point load, this 2 point load is there. If you want to convert UDL also point load where will act? Point load will act in the middle. Point load act will be middle, 1 meter and 1 meter. So this is 1 into 2. What is this one? Load. So kilonewton. This how much? 2.5 kilonewton. So this is the load diagram for this. What is this one? This is the load diagram for this. So when this will be helpful, once you taking the moment, now look here moment. Moment is equal to nothing but force into perpendicular distance. Perpendicular distance. So if someone not understands here, see this for the UDL. What is UDL? This is load into what is perpendicular distance? This is the perpendicular distance. So what is this length? How much? 1.5. This length is 1. So how much will come? 1 plus 1, 2.5, 3.5. So what is this one? 1.5 and 1 meter. So if we'll take length here, okay, now we are taking here now D. Taking moment about D only, yes, you see here. Taking moment about D here, this point. So what is the moment? 2.5 into this distance. How much this distance? 2.5. You see here, this is called 0.5. So 1 to 2.5. Taking moment about D for this, 2.5. Taking moment about this, what is the distance? 1 meter. So 1 into 2 into load, and what is 2 by 2? 1. So 1 meter only. That's why we wrote 2 by 2. So this concept also will be easy for you. Or UDL is rectangular load. So always once will take the moment load into center of gravity distance. So UDL center of gravity distance will be middle because this is rectangular load also. And also if you are understanding this concept, if you understand that will be more clear. Because we are converting load diagram. Moment is equal to force into perpendicular distance. We are taking for the U up to D only. So this is the distance, half distance. Moment about D na, load into 1 meter. Now if we'll take C, this also again it will be useful for that. Okay, so first value will write here. MD value how much? MD value will be minus 8.25. 8.25 kilonewton meter. Now look here, next moment I'll calculate now. Again this will be useful one for you. This is like key concept. So ME, now I'm taking ME, then we'll take MA. So this will be useful. So okay. So first we'll take the negative outside because due to the sign convention. Now come the point 2.5. 2.5 is there now. At E. At E, what is the distance? 2.5 into perpendicular distance. What is? 2 plus 2, 4. 2 plus 2, 4. For 2.5 moment over. 2.5 moment perpendicular distance. 2, 1.5, 3.5 plus 0.5, 4. Now, plus another UDL. This moment we have to find out. Because we converted UDL. So what will be the load? What is load here? 1 into 2 load. From E we are taking, no? So what is the half distance? 1. And where is this UDL? Or suppose we are seeing from the point E, no? So UDL 1.5 plus 2 by 2. But here see, direct length will take. This length how much? This length how much? 1 to 3.5. So directly we can write 3.5 here. We can write 3.5 here. Suppose you are considering here, what will write for E? You see here. 1 into 2 load. 1 into 2 load. Then 1.5 plus 2 by 2. So how much it is coming? 2 point. Oh, one taking moment about E, no? So E now 1.5 plus 2, 2.5. See here. We are taking moment about E only. So what is the distance? What is this distance? 2.5. You see here. If we are taking this way also at E, UDL, load, then half distance. Where is this UDL? After 1.5 meter. 1.5 plus 1, 2.5. Here you see, if you are taking about E, load into perpendicular distance. How much? 2.5. Okay. Any other load here? No. So this is the value will come. So 2.5 into 4. So ME the na into 4 ME load into 1.5 plus. Okay. So this value is coming minus 15. Value is coming minus 15 kilonewton meter. So this calculations or this calculation 1.2, this 1.2 and 2.5, or this will be same. If you will go this way, it will be easy for you. Now I am taking moment about A. You look here how it will come. First negative 2.5 you take. 2.5 total distance how much? From A total distance how much? 2 plus 2, 4 and 5. Total distance is 5 plus UDL I am taking. Now you come here. UDL I am taking now. So 1.2 load you convert first 1.2 load into perpendicular distance. Now you take 3.5. 3.5 directly. Okay. Plus 3 into 1. Close the bracket. Now look here. If you will see here directly here from A, what is coming? For UDL I am just for understanding I am doing 1 into 2 load, then 2 by 2 half distance plus where is the UDL? After 2.5. 2.5 away. So 2.5 plus 1 3.5. See 1 into 2 3.5 directly. If you will draw this, suppose moment you are not comfortable taking UDL half distance, draw the load diagram for this load diagram. So this is the UDL for A 3.5. Suppose E taking 2.5. Suppose here taking 1. This is the length. For moment about D, load into 1 meter. Moment about E, load into 2.5 meter. Moment about A, load into 3.5 meter. So this way you can find the moment. So what will be the answer for this? Moment about A minus 22.5. 22.5 kilonewton meter. So this concept, if you are understanding, it will be useful to calculate the any type of moment. So okay. So if UDL will be there, convert the point load according to the point A total distance this, E total distance this, D total distance 1. So like this we can calculate. Okay. So now we'll draw the bending moment diagram. So already value we got it. So now we'll see the diagram. Minus 8.25 kilonewton meter. Okay. So diagram will draw. So big work will be there. Carefully you have to draw everything. Draw, extend this line and all, thin line or dotted line you draw all the junction point. So there all point will be right. So okay. So draw the zero line first. Moment, bending moment diagram ke zero line, because in this line bending moment will be 0. So first this point bending moment will be 0. Bending moment will be 0. MC na point load. Point load is there. So it will be inclined line. It will be inclined line only. Point load means inclined line C. Now UDL is there between D and C. So how will draw this line here? How much MD? Minus 8.25. So this will be parabola will be there. This will be curve line. This will be curve line at point D. Now look here at point E. At point E 15. So we'll draw the inclined line. We'll draw the inclined line. Now at point A, no load. So here what will be there here? Here also inclined line. So again will be the inclined line. This will be 22.5. This is point A. This is point E. How much we got? E point 15. This point how much we got? 8.25. Negative already direction negative we cannot write. This is 1.25. C. So draw this hatch line. This is the bending moment diagram negative. So this way you can calculate the line. So what you can remember? Suppose point load will be there. Point load will be there. Inclined line for the bending moment diagram. If UDL will be there, UDL will be there, curve line will be there. If UVL will be there, that not there now, UVL will be there now, cubic parabola. That will come later. Suppose triangular load will be there then. Now this only, these two only we are considering here. for UDL, for point load inclined line, for UDL curve line, again for point load or no load inclined lines. Okay, so this way we can calculate the moment of bending shear force and bending moment diagrams. Okay, okay students, watch the video, subscribe the channel, share this video to your friends. Okay, thank you.